Okay, so what if I told you that one of the biggest leaps forward in robotics, well, it's not happening in some crazy high-tech lab. It's actually inspired by something you probably use every single day without even thinking about it. Yep, we're talking about the humble appliance knob. And it turns out it's a total genius when it comes to teaching our future robot assistants. So here's the fundamental problem, right? This is what we're up against with AI today. A robot's camera can look at a stove and its fancy vision system goes, yep, that's a knob. Okay, great. But then you ask it what the knob does, or, is the stove on or off, and you just get, well, pretty much a blank stare. It sees the object, but it has absolutely zero understanding of how it actually works. And that is the huge gap we need to close. And that right there, that's the robot's blind spot. It's this massive, absolutely critical difference between just seeing an object and truly understanding what it's for. I mean, think about it. For a robot to be genuinely useful in our homes, it can't just be a moving camera that goes around labeling things. It needs functional intelligence. It's got to know that turning a knob changes something, that a switch has an on state and an off state. Without that basic knowledge, it's just a clumsy machine that can't even do something simple like turn on a light, let alone, safely operate a gas stove. Okay, so how do you teach a robot that? Well, this is where things get really clever. Let's dive into the blueprint for teaching a robot to see. And it comes from this incredibly thoughtful project by the team at CoData. They developed something they call the Appliance Knobs dataset. The secret sauce here is a technique called multi-angle supervision. And the idea is actually super simple but really powerful. Instead of just showing an AI one flat picture, you give it paired images of the exact same object but from different angles. You give it a front view and you give it a side view. And that pairing, that is the absolute key. So here's how this actually builds that understanding. In step 1, the robot sees the front view. This is your classic object recognition. It goes, aha, that's a round knob. But step 2, oh, that's where the magic happens. Because by also seeing the side view, it can now see where the little pointer is. It can understand the knob's orientation, its state. Is it set to high? Is it on low? All of a sudden, the object actually has a purpose. And this one little shift in perspective, it just unlocks a whole new level of comprehension for the AI. We're not just giving it depth perception for distance, we're essentially giving it depth perception for function. And just look at what this unlocks. The AI isn't just detecting things anymore. No, it's developing genuine 3D reasoning, real spatial awareness. It can finally understand the state of an object. Is it on? Is it off? Full? Empty? It gets the orientation, which is absolutely critical if you ever want a robot to, actually turn the knob to the right setting. This is the huge leap from a flat 2D label to a real 3D interactive understanding of the world. And just look at the difference this makes visually. On a scale of comprehension, right, a single view approach gets you, well, basic detection. But the second you add that second, supervised angle, whoa. It causes this massive, game-changing jump straight into the realm of true understanding. We're talking more than double the comprehension. This is not some minor tweak. It is a foundational breakthrough. Now, I know what you might be thinking. This all sounds like a very specific problem, right? Just knobs on an appliance. But the principle here is absolutely huge. It points to a future that's all about being fine-grained. A future where small, really thoughtfully crafted data can make a giant difference. There's a quote from the source material that just nails this perfectly. It goes, "It might look simple on the surface, but this is the kind of fine-grained data that quietly powers major breakthroughs in embodied AI." I love that phrase, quietly powers, because it's true. It might look simple. I mean, they're just pictures of knobs, but this is what a quiet breakthrough looks like. It's not always some massive, flashy new AI model. Sometimes it's about giving the models we already have the exact right information they need to learn a brand new skill. And that's why this is so much more than just a data set, a collection of images. Think of it like a single, absolutely crucial Lego brick. It's a fundamental building block for any machine, any robot that needs to physically operate in our world. And you can apply this same principle to levers, buttons, sliders, doors, you name it. So really, the most crucial point is this. For a while now, we've been obsessed with building bigger and bigger AI models, just feeding them the entire internet. But what this project shows so clearly is that the path to truly intelligent embodied AI, robots that can actually function in our world, it might not be about more data. It's about smarter data, more thoughtfully structured data. It really is quality over quantity. And that leaves us with a pretty fascinating thought, doesn't it? If a simple appliance knob can teach a robot how to think in 3D, to understand function, what's next? What other everyday objects are just hiding in plain sight, waiting to become the next great teachers for these incredible artificial minds we're trying to build?